Hello class, this is Research Project Checkpoint 2, and the project we're working on is Code Mapper Artifact Reproducibility Study by Team WAM. And the agenda is project overview and artifact selection, sprint planning and team setup, process strategy, looking at our branches, PRs, and code reviews, and development progress per team member, as well as the demo, and showing the sprint 2 planning after, and as well as any other questions.
The artifact we focus on is CodeMapper. It's a language agnostic mapper for code regions across commits. So given a region in commit A, it finds matching regions in commit B. The reason this is important is because it allows us to report F1 scores and annotate Java data tables to see how much code is changing with CodeMapper and agents interacting with it. Why is Artifact and what was missing? It has strong research contributions, but no automated tests in the repo. So this produces a high reproducibility risk. The paper numbers can't be checked programmatically. Someone reproducing this has to check it manually. There's a lot of onboarding friction with new contributors and no safety net for changes so that they don't know if they're breaking core principles. And our Sprint 1 goal overall was to set up a Pi test suite covering those core modules and make sure if someone new is onboarded, they don't just break the core functionality. Stretch goals for later sprints are replacing the prints with like actual logging and fixing the forced checkout data loss path. In terms of sprint planning, there was a backlog on GitHub issues under our Epic one. That's where we addressed those. There were six parent issues, which were issues 2 through 7, or Epics 2 through 7 for us, with that were then broken into 21 child tasks. We had two milestones in general: Sprint 1, which was infrastructure and core unit tests, and Sprint 2, which was our integration tests, CI, and coverage. Issues were split across all three of us, and then my slice individually covered 28 issues for testing structure, data structures, utilities, GitOps, stuff like that. Overall, there was one feature per branch per parent issue, so six branches in total, plus one mock submission per the professor's requirements. There was a conventional commit message with closes and to auto-link issues that we learned earlier this semester. Pull requests were against the target main. We would stack dependent PRs on top of each other so that they would merge in sequentially once they were reviewed. Overall code review was done by one other team member. The GitHub action would run the Pi tests on every push to main, and then our coverage HTML uploaded as a CI artifact for the review. So development progress per team member. So I'm first up. Overall, I owned the test suite Epic #1 end to end. This broke down into 28 individual GitHub issues that I pushed across 6 PRs plus the one mock submission PR. Overall, this was 95 passing Pi tests in the suite, going from Python 3.1 to 3.11 with the HTML coverage artifact in there. Um, Overall, it was a 30% aggregate coverage rate, which was lower than I was hoping for, closer to 40. But per module, if you look at it, is about 80. I split the work into one branch per the parent issues. Um, these are all of the PRs that I took out for the PyTest configs, CI stubs, all that type of stuff. We can see that across different structures, there's like different amounts of unit tests that were created or fixed for coverage. Under the modules tests, I tested core data structures, utilities, measurements, phase 2 rankings, which was the compute target region, which was important to the actual real critical component of CodeMapper because at its end goal, we need to tell you how much code is changing between regions, between commits, and then phase 1 helpers too. So some findings worth flagging. Get target file path calls the repo.get checkout and it allows you to commit force true. This silently discards uncommitted changes in any working repo, which would really mess up all other colleagues' work. So now test capture this as a fix, so it shows up as a test diff before something like this happens. My coverage snapshot overall, like I kind of stated earlier, was overall for everything that I worked on, I got about 35%. Lower than I wanted. Like I said, I wanted closer to 40% of highlights. So I got 100% on these these test regions. So candidate region, diff hunk, compute overlap between two strings, and then I got pretty high coverages on like character range, one round time info on read file. But then this is where it started dropping off when I got to like file paths, compute target regions, and other like get to diff candidate regions. And I think this is because the behavior between those code parts um threw off the unit tests that I kind of helped develop.
So I'm up next. I own the CLI Epic, and I contributed over 20 GitHub issues and closed one across one feature PR. And I had overall 36 passing PyTest tests across four different test files and code mapper console script registered in the PyProject TOML. And this is kind of worked on. And all measurements and tracking classes are lazy imported. No more heavy dependence at startup. It makes the code mapper run a lot better. And so this is the overview of my PRs. The kind of PR 45 I worked on the infrastructure, establishing testing foundation with PyTest configs, and adding on top of Munish's work. And I implemented 20 unit tests covering the character range, diff hunk, and other core models, supplementing the other modules. And I added 30 units tests for logic helpers, including compute overlap and transfer ranges. I also work on measurement, such as developing 17 tests for scoring metrics and target region computation. And the other stuff I worked on GitOps, CI coverage, and final delivery by consolidating all the PRs into a 95 test suite with 35% coverage overall. CLI entry point, I worked on anything tracker.main, and the modules I was testing was the track sub command as well. I also worked on track history pair suppression. Second thing I worked on was evaluating subcommand. Anything tracker CLI dispatches to work on a file, measure annotated data, and also worked on the measure suppression command as well. Second of all, I also visualized the subcommand when it's called, as well as the visualizing the execution time. And kind of the issues that worth flagging as I worked on this is experiments and measurements subpackages had no init py, and a lot of I had to first resolve a lot of these kind of setup issues first. And module paths for mocking, I also added that into the program. Also, I added tracking scripts for importing fast edit distances at module level. It makes them unimportable in test environments. And without the full dependency stack, we used sys modules to patch to stub the entire modules before lazy import fires, making the program run more smoothly. And I resolved dependencies in PyProject and also migrated them. And kind of a coverage smasher, I did 100 on candidate region, diff hunk, compute overlap between two strings, and fine-grained white spaces. I dropped to about 94% on character range and one round time info. 50 and kind of the across other files, I had 53 on get target file path, 36 on get diff, 31 on detect movement, and kind of the lower ranges, 11 on search lines to candidate region and read file, 5% on fine grain line character indices, and 0 on the other files that I did not touch as much. I'm hoping to get this up by the next sprint.
Hey, so I'm going to go over the contributions I made to the repo. I contributed to the CLI feature end to end. I added the new source anything tracker CLI package with 4 modules wiring up a single entry point. There are 6 passing PyTest unit tests covering dispatch and error handling logic. The code mapper script registered to the PyProject file, the help command, and surfaces all subcommands. Replace the manual if. Oh, can you go back?
Yeah.
And I replaced the manual if name equals main convention script editing with a 2-command fast mode workflow. The main.py top level argparse dispatcher it now registers code mapper script in pyproject.toml. Evaluate.py code mapper evaluate dash dash dataset argument was added to help the ease of using the repo. Visualize.py code mapper errors.py shared helper that prints errors and with different flags. Test slash test CLI evaluate was 6 unit tests covering error pass and happy pass path dispatch, and then documentation with the test scope file. 3 new in-scope rows documented the CLI module coverage. So modules that were under test. Evaluate dispatch, these 2 modules, the visualize dispatch, the arg parse layer, the error surface, test seam, dispatcher routing assertions, dataset name, and approach forwarding to the measure classes, and then doc surface, test scope dot markdown, in scope table rows for now the CLI main, CLI evaluate, and CLI visualize. And then some interesting things worth flagging. Evaluate.py and visualize.py previously required editing hard-coded variables inside the if name equals main convention blocks. The CLI wrapper now exposes them as flags, so misuse fails loudly instead of silently running the wrong config. Bad inputs print exact valid values to the standard error instead of a Python traceback. Errors.py centralizes the message format, so any new subcommand inherits the same user experience. Adding a dataset or RQ is now a one-line change to valid datasets. Paper's fast mode is reproducible as CodeMapper evaluate, with the same as CodeMapper visualize. And coverage snapshot, here's some coverage details that I obtained. 35% of full anything tracker package. There's other information here. Overall, it was a pretty good coverage report. But like what Muni said, I wish I got a little bit more than that 30% at the bottom. So to demo assemble test suite and CI, we tested live with PyTest run from a fresh clone. We got about 0.7 seconds with all 95 tests passing. We also tested PyTest with this cov argument, producing the per module table. The GitHub Actions run on PR51 with the coverage HTML artifact attached. The feature branch PR review merge flows on PRs 45 through 50, and then coverage badge on the README. Sprint planning, this is to continue working on this project if we were to continue. So things we'd like to do and improve is raise coverage gate from about 30 to 50% as more modules get tests. Cover the ablation modules, disable component, and various context sizes. Replace print calls with the logging module across anything tracker. Fix the force equals true checkout and get target file path behind a feature flag. And we also want to add this slow paper claim test that runs the tracker on data annotation and annotations.json. And then finally, we'd like to migrate runtime dependencies from requirements.txt into PryProject.toml.
So kind of looking back over the entire process, what worked was our workflow of 1 PR per parent issue and then conventional commits with closes with the number tracking. This made it very easy to track our current progress, and also stacking dependent PRs so that reviewers can see clean diffs after merging. What actually did hurt was the PyProject toml dependencies. Having a blank and editable install missed runtime development, and this is one of the features we wanted to improve on if we were to continue on working on the next sprint. PyTest exit code 5 on empty branches also needed a workflow wrapper for better debugging. And going forward, we want to open a CI workflow PR earlier so the empty collections issue was fixed up front. And this is our repo, and any questions is available here.